token economics, agentic systems, and AI factories. What must architects rethink? To moderate this discussion, please welcome to the stage Dr. Vishnupriya Raghavan.
Thank you all, and thanks Amit, Bala, Vijay. It's a new challenge. We have to design systems that is not only economically, that's not only intelligent but also economically viable. Now, all along we have been worried about cloud, compute, APIs, cloud costs, and all of that, right? But now it is shifting. Now, my first question to you in that is, now in this whole thing, architects now do not have a choice but to rethink platforms, operating models, and enterprise architecture. Right? Now, before I go into the individual rounds, I first want to hear your perspectives because three of you bring very complementary strengths. Bala, you come from an enterprise tech strategy background. Amit comes from large-scale transformation, platform adoption. And Vijay, you are from hardcore platform engineering, real-world implementation, right at that level. So all of you bring that kind of strengths. So my first question to you is, what is happening in your world today that makes this conversation relevant and urgent? So can we start from Amit?
Thanks. There's a topic that every enterprise which is trying to embark on a journey of Agentic AI. And the world of Agentic AI seems like a fabled world. You cross it and there's so many benefits on the other side. But the challenge is very few people are taking into account the cost of that kind of a transformation at an enterprise level or the cost of implementation. I remember my early days when, something had come up with a client and I went and I advised the senior leadership within that client organization that we should actually not be implementing AI in this case, and that entire room fell silent. Why? And I said, it doesn't make sense for you economically to do this because the build cost is fine, the run cost is going to be significantly high for you, and those were the early days of generative AI. So, the economics is not just about building the systems, but also about running the systems and very efficiently running the systems. And that is what makes this space very interesting, very intriguing, and brings in a significant kind of a different kind of a thought process on people.
Thanks. Thank you, Amit. Bala, your take.
See, basically, first of all, thank you, Priya, for inviting us and wonderfully put up World Digital Architects Conclave by NIIT StackRoute RPS. I think now it is NIIT Enterprise. Thank you for bringing all architects together. Round of applause for them. So first of all, I would like to say that last 20-30 years, we were trying to design the systems where we can move the data efficiently, primarily because of the increase in exchange cost. But now, we are minded to design the systems where we can make the decisions more efficiently. That is a subtle difference what we need to really look at, and that is where the architect's role comes in. And we are also witnessing in TCS that plays a very important role because every prompt has a cost, every reasoning step has a cost, what you see, every inference what you're trying to derive has a cost. So all these things are really boiling down how you try to collaborate across these particular regions. As Amit mentioned about economics of scale is completely depending on how we are interacting. The architects now need to really look at, are we really need to send every particular prompt to the complex model or we need to distribute it? So in order to put simple and short, we are not only building, as an architect, we are not building the intelligent systems. We are building economically viable intelligent systems. That's a difference what I want to get.
Very valid point, Bala. In fact, there was one slide exactly on this in Dr. Amiteshwar's presentation this morning. He says it's not about automation anymore because the world there was largely predictable, and today you don't have. There is so many branching that can happen. There is so much call-outs that can happen. So the entire orchestration has to be managed responsibly. It's not about managing automation effectively. So I think you set the point very nicely. Thanks, Vijay.
Thank you. Definitely. See, I'm going to give the perspective from a system integrator. So we are dealing with clients who are in the face of, they're across the face of experimentation. They've already started seeing the results. And now they're in a stage whether the investment, whatever they are making, is giving them results. Now we have to give them solid data to make them understand, yes, the investment, whatever they have done, is worthwhile and giving returns. The outcomes are something which they're going to see. So that is one part, right? So how are we going to do that is something which we are building internally as an accelerators. So we internally has started investing in accelerators like the Nebula which we showcased today, and a couple of other accelerators which will help us to envision what the end customers are trying to build, and also make sure also give them a feel that whatever they are investing is going to give them the right outcomes. So from a system integrator perspective, we are also building a lot of systems in place which will help us to keep a balance or check on the kind of intelligence which we are generating for them. So that's how we manage.
Thank you, Vijay. I mean, I think for the first time in history, intelligence by itself is becoming a meter resource.
Yeah.
Right. So now the question now goes to Bala. Bala, you are working with so many organizations, moving them from pilots to the experimentation, then to scale and all of that. What is the challenge on the ground? The challenge is the intelligence itself or the economics of intelligence?
A very valid question to the context, I would say. In the recent past, when the cloud came in, I just want to draw the analogy and come to the question, answer the question. What we have witnessed is people were trying to embark on the cloud, fearing of missing out, and people say that can we move our applications onto the cloud? That was the first question. But after a couple of years, they started. Is it feasible, viable, economically feasible to have the applications run on the cloud? The question changed. Similarly, now we are trying to witness a similar kind of a landscape of questions coming in. We have built agents. Building an agent is so easy nowadays. We have a lot of agentic frameworks available. Hyperscalers are providing. A lot of third-party players are providing. Build an agent, running an agent, and getting your tasks done. Additionally, deploying the skills is all possible now. Now, what is happening is once you start deploying the agent, now we have witnessed a very good demo on the agent prism, right? That was trying to show how the agents are getting used. When millions of people, say for instance, thousands of users within the company start using it, there's a millions of tokens getting generated and getting hit to that particular model for the consumption. So that's where the economics comes in. Now we have witnessed, especially in a small scale of research engagement, we were trying to look at what is the possibility of how this particular token consumption happens. Traditionally, we have a determinist cost when we are trying to use the functional programming language. We know exactly what is the maintenance cost of that. But in the context of the agents, when we have deployed 10 agents only, we have given a budget of $1,000 and made them run for a week. And we do not have a control on how the tokens are getting generated and utilized. Absolutely no control. Since we put the budget constraint, it got wiped out in a span of 2 days. We budgeted it for 1 month. Within 2 days, we consume the cost. We don't know what to do. So that is where the thought process started triggering. Architects, as an architect, we all should really look at what is the right model, what is the right time, and what is the right task. We need to choose this. Are we supposed to send every request to the complex workload, or we need to send some of the workloads to the inference models, some workloads to the domain-specific models, some workloads to the specific models, which can be small language models, which can be edge-based deployments. Based on the nature of the intent, nature of the query, nature of the purpose, you need to distribute. And that's where the distributed reasoning comes in. And distributed intelligence comes in. And economics of intelligence is really piling up now as a thought, as a challenge. Every architect now should look and evaluate themselves as a CFO of an organization. What CFS does, they try to look at the budgets, right? We need to look at the budgets, how agents are really consuming it, and how I can efficiently distribute these budgets so that I'll be able to achieve the right cost metric achieved. Otherwise, you are going to bloat up the cost and you're going to shelve the projects, not let lead to the production. In fact, there are ample number of projects available which have successfully completed the pilots. CFOs, CIOs have stopped them upgrading to the production. They are not pushing it to the production. They are evaluating the costs. They are saying, can you get down the cost to 80% low from what you are estimating? If you are able to do it, fantastic. Architects, relook at your architecture.
Very interesting point. I was at Hyderabad last week at one of the other conclaves, and one of this discussion came in saying that are we training our architects especially to look at the economics of problems, right? Because then I was thinking, when I was doing my MS, there were these elective courses, Engineering Economics 101, Technology Management and Economics 101. I don't know how many of you did that, but I promptly didn't even enroll for those electives. I went in for other courses, right? Now, decades later, now I realize how so much important these topics are, and I think they are coming back in the game. Right, thanks, Bala. Question, Amit, to you is now, from whatever Bala said, looking across enterprise deployments, because you're doing so many things at scale, where are organizations underestimating complexity the most? Is it models, data, orchestration? Where do you think they're underestimating the complexity?
The short answer is everywhere, but I think the entire part, which is associated with the tokens, is something that people have really not understood properly. I actually have a question for the audiences. How many of you all are familiar with Keep the Change program that Bank of America had launched? Yeah, good, please. You can talk about it, right? So it was essentially just diverting the change, asking the customers to sign up and saying that, hey, if there is a change, just divert it to charity. And they were able to collect $1 billion, I think, in less than a year of the start of the program. The first year itself, it yielded upwards of 2 billion or something like that. Token economics is exactly like that. When we look at the tokens and we say the cost of the tokens, input token, output token, 2 cents for so much, 5 cents for so many, it is nothing. But the moment you get into the agentic world, where the context gets multiplied with every turn, where based upon the complexity, the token consumption increases exponentially. These costs become significantly high. So that's a part that people have not really taken into account. And that's a part that is difficult for people to manage today. We've done a lot of client conversations. There are clients who have come to me saying that I want to modify my entire business process operations, invoice processing, and expending so much of, so many dollars, and then kind of come up with a cost for processing every invoice. We've got, we are expending close to around $7 or something on an average. If I was to replace it with an Agentic AI system, then you are surely around the saving around it. And it's very difficult to put in those kind of models today, right? Because controlling that system, specifically where you have got multiple agents and agents talking with each other and taking autonomous decisions, is very, very difficult.
So then, thanks, Amit. Vijay, question to you. Now, you can't tell your customers keep the change, right? Every tool interaction, every agent interaction, every little thing has got a cost to it. Now, how and why then the agentic architecture becomes different? from the traditional workflow automation?
Well, see, these are two different engineering problems. The traditional automation, it's more of deterministic, right? It is bounded. We know what we're building, and we set the perimeters, we set the boundaries, and we set the rules. So the system works within that. The other side of the equation is it is non-deterministic, it is unbounded, it is probabilistic, right? The agents work. Now, when we talk about non-deterministic areas, the biggest difference is the advantage is it will capture or it will satisfy or it will answer most of the edge cases, the tail edge cases, which you have not thought through in a deterministic world. If an workflow or if a system fails in a deterministic world, it's going to fail subsequently whenever it occurs. But in an agent world, it might fail or it might succeed. If it fails, it again reaches into that failure model and then regenerates it, reasons it, and make sure that all the edge cases are getting taken care of. Now, when we are considering the deterministic world, the cost is defined. We know what we're getting into. We know what is that we're going to spend. We know what kind of inferences we need for us to execute certain certain activities. But in agent, a group of agents work together. Who drives the system defines the cost consumption. In deterministic world, the traditional workflow, the architecture defines the architect defines. But here, in the agentic world, it's the agent who drives the whole processes, right? It might take a turn, or it might pass on the knowledge to the other agents. So the cost compounds. That's the very nature of it. And it's not that the cost compounds only when the outcomes are positive, right? The cost, we're going to incur the same cost even if the outcomes are not going to be very positive, meaning negative, right? So even the failure is a cost over here in the system. So that compounds. So basically, in an analogy, let's say for an example, when we are building an metro systems, right? So we know for sure the way the green line goes, the blue line goes, the yellow line goes, and there is a definite routes applied, and there is a definite cost applied to it. But in the agentic world, it's kind of you deploy certain taxis or drivers, and then together we are asking them to figure out how to reach the destination. So we never know the path which it's going to take, right? So in that case, what happens is automatically we'll end up inferring more costs. But the advantage is most of the edge cases, whatever we have not thought through, it's getting covered in this approach. So that's where the difference is.
I have a follow-up question for you on the same lines, but before that, we are going to ask two questions to the audience. Can ask two questions at the end of this round, so you can keep your question ready. The follow-up question on the same lines, Vijay, that you said. Now, if there is a cost that you set for everything. Now, if there are 20 collaborating agents, how does the architect decide the level of autonomy to decide when does the cost of the agents exceed the cost of the value that is being provided? Or in other words, if I have to go back to economics 101, the point of diminishing returns that all of us studied, right? So that is my question. So when do you take that?
A straightforward, simple rule. As long as your failure parameter is narrow, you can give more autonomy to it. As long as you are able to verify the responses in a broader sense, you can give more autonomy. When the reverse happens, then you have to jump. You will not be able to give the autonomy to the agents, right? So the failure parameter has to be lesser, and the radius of the landscape when you will be able to verify the outcomes. If it is larger, then you can start giving more autonomy to those agents. That's how I would give it as a simple concept. Define when you can give autonomy to it.
Great. Questions from the audience for this round? Yeah, because they spoke about the economics of intelligence. We spoke about the cost that is incurred at every step. Questions?
The question I will go back to Vijay. For token economics, I feel that, by the way, I'm from university. I have the same issues which you guys are focusing. I feel, but we are mixing two things at the same time. Number one is the projects have gone to outcome driven, business outcome driven. Second is the SDLC, the methodology is changing to agility. Maybe the mix is causing the confusion. So I'm asking the same example you told. Building the metro. Yes, it would have taken some cost with normal and some cost with agent. But suddenly we are looking at outcome. And some person is saying that I have reduced my time from here to office by half. But after metro also, because of the local convenience, I am not reaching there. That doesn't become a metro problem. So my question is that, do you see that in your projects, this mix of outcome and agent comes together? And since agents are very flexible, as you tell in the loop, they keep on correcting, the requirements keep accumulating. And is that the reason for the cost explosion?
Well, we can take one example in the STLC phase itself, because you just mentioned it. Let's say, for example, we have set up an instruction to the agent. Let's say, for example, it's an PRP builder or a requirement elicitator agent, right? So while we set the instruction itself, we give them a standard instruction saying, hey, this is where my PRD should look like. Say, for example, it should have 10 different bigger items, and then each and every item should have at least 3 or 4 items checked. So that is the spec which I have given for my PRD agent to produce. Now I could also give another instruction saying, you will be able to proceed to the next level unless and otherwise you would have created all those 80%. You should have checked all those requirements which I have specified in my PRD elicitation, right? Now, what I'm instructing the agent is, I'm telling that you can proceed to the next level if you have reached that outcome of 30%. Now, for me to reach that 80% outcome, how much is that I'm going to invest? Am I going to invest 45,000 tokens? Am I going to invest 30,000 tokens? So if the agent has approached that 80% check levels, and if I have consumed only 50% of the token which I have commissioned it for, then I have a win. So the outcome is always based on, the outcome has to be validated against the kind of investment whatever we have made. As long as it brings it, with values, we should be able to proceed. Otherwise, we need to jump in and then check and then start instructing the agent saying, whatever we have done is so far is good, or whatever we have done is not good, but proceed. That kind of interaction has to happen. So the outcome is always validated by the kind of investment we have gone into it.
Thanks. Any question for Bala and Amit? Yes.
Yeah, I'm Vikas from Tata Elxsi. My question is, instead of using the LLMs from the big techs, why don't we have our own? We have so many LLMs open now. So there are about 70 billion tokens or parameters or 120 billion parameters. LLMs are available. So we keep in our hardware and our infrastructure. So one time cost is there for the infrastructure. Then create a hypervisor layer, and all your agents will run above the hypervisor layer, and where you choose your agents will choose the appropriate model, so that the token cost can be completely made. We can make it zero. So only your cost is infrastructure cost. So why can't we go for such architecture?
Indeed, you can go for that architecture. With you on that, AI factors is the short answer for your question, if you really wanted to achieve that objective. But you also need to be aware of the fact that earlier infrastructure was most of the important cost we used to incur. Now intelligence is the new infrastructure. So after building the software, intelligence does not come to you free. So if you're really looking at the overall phenomena of the costing of economics associated to the tokens, token is a proxy of reasoning. And if you are trying to say the reasoning cost can be reduced by putting this particular thing, running your model in your AI factory, which is local to your data center, indeed that is the right approach. But there are different optimization levers which you need to really look at it, and that will really allow you to optimize the things better. AI factors is one of the solutions, which NVIDIA is also promoting nowadays. And I believe one of the poster also I've seen people are trying to talk about the AI factory, which is again a good sign and the method they are trying to use. And I believe OpenShift also talked about the AI factory. So that is also a kind of an indication that how can you bring AI factories to reduce your token costs.
I have a point of view to share. It depends really on what kind of enterprises we are discussing with. We have dealt with both sides of the equation. There are big enterprises which comes up with very specific request on dictating terms on governance and content stream space. Then in that case, we have to align with the hyperscaler provided LLMs models. Because they come with all those pre-configured guardrails and checks and balances in place. But when it comes to open sources, we take the ownership and we have to make sure that all those guardrails and governance are baked in. And it takes a lot of effort for us to certify that, right? So that risk factor will also has to be considered while we are choosing between which way to go, whether to go with the hyperscalers or whether to go with the local models. Cost cannot be the only factor for us to decide. Yeah.
Bala, you spoke about the optimization levers, right? So we have discussed a lot of that in cloud costs. Because you spoke about that, I'm just asking that follow-up question. What are the optimization levers here in this case? I mean, at least some of them will go with some peace of mind and maybe you tell them that.
Okay. As an architect, again, let's go back to the cloud. When we are trying to design the solutions and architect solutions for the cloud, we were trying to optimize for the cloud. We are trying to optimize for the storage, network, many such elements. Now, we are trying to optimize for the token usage. Or complete mindset is changing. There are certain areas where you can really look at. First important optimization lever is model selection. So as I mentioned in my previous answer also, as an architect, how many of you are designing the solution to choose different models for different prompts or different intents? Whether it is a lightweight model or domain-specific model or inference model or a complex workflow model, how are you distributing your workload to get the work done? The second important optimization lever, I personally see it as a agent orchestration. You know that reasoning is there every time. Now, every time when you want to reason, let's say for instance you have 5-6 agents running in your environment, and if these agents start debating for every particular decisions, it consumes a lot of tokens. You need to really understand the essence of whether each decision need to be debated by everything for achieving the required business outcome. If it is necessary, you can go for it. If that is not necessary, then you should avoid it. So how you orchestrate your agents to work together is very, very important step under which you try to operate. The third important area is about caching and reuse. So not necessarily that if it is already computed, the reason is answer is available, you don't want to hit the model once again. So how you are going to cache and leverage this particular metrics which can really help you to do that. So the reuse of that particular elements will play a very, very important role. The fourth important thing is about, I heard also from the others, but before that, I want to touch upon context optimization. This is a very important step as an architect what we need to really look at. You are running the model, getting the response. How are you optimizing your context? How are you measuring your prompt quality? I heard one of the participants also referred to the prompt quality. Prompt quality, context quality, inferencing, all these things plays a very important role. Optimization at the context level can improve your entire thing. In fact, I have seen I have attended the MongoDB.local event recently. I don't sure whether I should say this or not, but they are trying to come out with a very predictive intelligence layer, where they are trying to bind enterprise memory, they are trying to bring in the vector search, they are also trying to bring the context engineering as a skill. These things can really improve your token costs effectively. That's a context optimization, context engineering can play a very important role. Fifth, but not the least, is about AI ops need to be binded by the AI FinOps. Now, we have seen from the agent prism of NIIT demonstration, which is wonderful. So, if you are trying to bind that with a FinOps strategy, you exactly know which agents are consuming more and how can I optimize. Very good input example from Prasad, where he told that I can replace Opus by Sonnet because he saw some kind of a dramatic change in improvement in cost quality. These are the agent monitoring will really help you to that achieve that objective of optimization and move in that direction. So tomorrow's architects need to really focus on how we apply these optimization levers when you're trying to push your architecture and realize that architecture with the code into the production. Because we are not burning the cost, we are optimizing the cost.
Yes, thanks, Bala. Amit, now, whatever Bala said, you are from the large-scale enterprise transformation and platform adoption and all that. I'm sure you are doing a lot of work on the AI factories already, right? And he spoke about all these optimization levers and all of that. Do you think this really works when you're setting up large-scale these kind of factories, number one? And number two, how do you see this very different from the other platforms that you've set up?
So, fundamentally, a lot of people thought about AI factory as just an upgrade to the current set of software factories. Thought, you have the infrastructure, and all that you need to do is to put in a few more additional GPUs, and that's it. You got the stuff for AI to work. It doesn't work like that. AI factory has to be designed fundamentally for hosting probabilistic systems. It is different from the software factories that we've been designing and we've been setting up today for deterministic systems. In a deterministic system, it's like Newton's first law of motion. You all remember the Newton's first law of motion? Yeah, basics of physics. Any body at rest or at motion will continue at rest or with that same constant speed and in that direction till an external force acts on that. That's exactly how the world of software factories is made. When a software program is written for the same input, it will continue to produce the same output on the first run, on the second run, on the third run, on the 1000th run. But that's not how it is with AI. The moment you enter into the probabilistic world, that world itself, that entire thing itself is geared to improve over a period of time. So the output that you get in the 100th run should be better than what you received in the first run. What you got into 500th run will actually be better than what you got in the 100th run. Right? So subsequently, as you move, it has to be better. Therefore, AI factories have to be designed fundamentally for cognition. So, if software factories were for these kind of applications, data factories, are for reports. Then AI factory is for cognition, essentially providing an architecture for intelligence within the organization.
Wonderful. Thanks, Amit. Any question for Amit on this point? Any question specifically for Amit on this point?
Either on this point or any other point.
Anything for Amit? Yes.
Not on this one.
Go ahead.
Fundamentally, we are discussing this because of your mention about the cost of it. I want to get your insights on this will go down. We should not only do some cost for the next 3-5 years. We are over architecting this now and then we realize after coming the total cost will not have weight. And we always see more competitively. So we not put to take a pause and rethink that.
Yeah, it's audible. I'm loud enough. So, is it not good to take a pause and rethink about how this industry actually is moving and what is your insights on those big players? I hope there will be a fair economy going on there, Anthropic and other chat players, etc. Will they bring the token cost down realistically.
I
And
mean,
then
ideally, yes. I mean, if you look at,
Sorry, I didn't get your name and organization.
I'm Sunil from Elsewhere.
Sunil. Okay.
I think, sure, that yielded the best results. The moment they started putting on transaction systems and data warehouses and all that, see the costs, for the high compute nodes and all significantly drove up the costs for a lot of them. Now, the agentic world is very different. The difference here is you are giving the autonomy to an agent to run and build out, to run and kind of really look at how much of refinement of an answer is required before it says, yeah, I'm kind of satisfied with the response and gives you back the response. So that agent can essentially eat into the costs, consume the tokens, and as I said, the token, with the subsequent runs, the tokens grow exponentially. They don't grow linearly, right? In our current world, you'll either have a logarithmic growth or you'll have essentially, the rate of growth is linear. But here, the rate of growth is exponential. And therefore, even if the costs come down, it's extremely important for us to fundamentally architect the systems in such a way that we are able to make them economically viable. Although there is another state of nirvana, and I'll talk about it slightly later, which might help you.
You tried to ask a very provocative question. And this is a seasoned leader with 30 years of experience.
Yeah.
He made sure that the answer is very politically correct. So,
Can I challenge this a bit? Sorry.
yes, yes.
In contrast to all the technologies that we have seen today, for every page that's written about the positives of AI, there is a page that's written about its definite. The biggest challenge we have with AI is it's just beginning to get used. We've not seen scale yet. Second thing is we have limited resources. We are kind of peaking already on number of GPUs available, memory available, bandwidth available, etc., etc. We heard in the morning $5 trillion already sunk. Right? Is it not more real to say the cost will only go up? It is never going to come down in the near future.
I think, let me take the first stab at it and then follow. I think you're absolutely right. I mean, if you look at the investments that have been done by OpenAI, by Anthropic, by Google, they need business worth more than $600 billion a year on this to break even. This is data as of March of 2026. Since then, probably it has, the numbers have changed even further. So, there is definitely a kind of a risk around enterprise scale adoption at the kind of speed which we are envisaging today. However, the changes that AI is going to bring in, these are not new. I mean, I've been doing AI now pretty much my entire career. AI is not new. AI was being used, when I was in college. I was working on a project with ISRO and we were doing certain things at that point of time where we were trying to kind of look at the satellite imagery, and that was the time when I had to write some 6 pages to implement a neural net in C code. Today I have to just make a simple Python call and the entire thing happens. So AI is not new. AI has always been around. It's just that there's a significant amount of infrastructure that is available, low compute power that is available, languages have evolved to make it much easier for people to utilize it. And with the transformer-led architecture that came in, powered the LLMs, you're seeing this entire growth of agentic and all. There are systems, if you look at the defense industry, if you look at the space industry and all, AI is evolved and is being used in a big way over there significantly. It has scaled up there. So it's only a matter of time when it's going to scale up and it's going to be available in the commercial industrial world as well. The question though is going to be whether that state is going to come in the next 1 year, as a lot of these hyperscalers are talking about, or is it actually going to come in the next 3 to 4 years? My own assumption is it's going to take a little bit more time than what the hyperscalers are saying, because a lot of organizations are not ready with for this kind of a change. This is a massive change. The moment you move from the deterministic world to the probabilistic world, it's a massive change across security, across compliance, across your ability to go in and audit things around what happened, why a particular decision was taken, by the AI system earlier. There's so many different things, so many different aspects. There's an aspect around, the change of the human aspect, people aspect, all the different changes that would be required. And that change management is going to take time. It's not going to happen overnight.
Just a follow-up. We've seen these large investments happening for new technologies in the past. And one thing which ensured that the cost didn't have to get carried over is that 3/4 of the guys vanished. So all the money they had spent is written off. It's not to be paid back. There's likelihood of that happening as well. Therefore, we shouldn't keep saying that 70. A lot of it will go. So that will cut down the cost of one level. Second is this whole issue of saying that just like we still have some 80% of code on ATMs in the US is still third generation languages coexisting. What is the possibility of portfolio approaches happening, which means some things which are deterministic, do them at 1/10 the cost. And therefore a portfolio view as against a linear view of saying everything you're doing will be on these tokens. So could these two be reasons which make things workable?
Yeah, it is. I think that's how the change is going to happen. It's not that every enterprise is going to change overnight and become a complete AI-enabled enterprise. In fact, for a very long period of time, just given this kind of token economics that we are talking about, a lot of functions would still be more economically viable if they continue to be done the way they are being done today. But, over a period of time, as the cost of tokens continue to decrease, as technology itself evolves further, you're going to see more and more of that intelligence coming in. The change that you will find is, if you look at these kind of shifts that we have had, all of us here in this room are not new to technology shifts. We've all seen the different shifts happen. The rate of that change used to be spread over a number of years. The rate of this change, though, is going to be faster. Right? So it's going to be faster. How fast, that is difficult to predict. Whether it is going to take 3 years, whether it's going to take 4 years, that's difficult to predict at this stage.
So we were running the time, but before I call Pankaj up for presentation, I just have one line answer I request from each of you, a very quick rapid fire. Bala, if you were an architect in this audience today, what is that one topic you would spend the next 6 months studying deeply, or next 2 months studying deeply? One line.
AI systems architecture.
AI systems architecture. Okay. Vijay, what is that one assumption architects hold today that you would encourage them to challenge?
I don't think that cost is going to come and hit you later. Make it into a design itself.
Okay. Amit, when we meet again at the World Digital Architect Conclave 2027 next year, What do you think will have changed most in this discussion today?
Probably a few more gray hairs. But I think definitely you will have a few examples of enterprises that have put critical business functional systems onto AI.
Thank you, Amit. Gentlemen, ladies, please put your hands up.